Hello, and welcome to Physics for Play. In this episode, we're going to be looking at why we chose Mathematica. What are some of the pluses and minuses to using it for playing with physics? Let's get started. For the most part in this video series, we're going to be doing most of our computations in Mathematica. Mathematica is a software that's built for technical computing, and it has some advantages and disadvantages. So I thought it'd be good to talk a little bit about why we're choosing Mathematica for these particular videos. So I'll start with the advantages. In general, as I mentioned, Mathematica is widely used for technical computing, both in academic groups and in industry. It features easy to use notebooks, much like Python, although Mathematica was doing this even 20 years ago, so they have a bit of a head start there. One of the things that I love about using Mathematica is that you don't have to worry about things like packages or versioning for the most part. I feel like in the past when I've used things like Python, I spend half my time trying to make sure I get the right packages to work and be compatible with each other, and not enough time actually focusing on the scientific parts of the problem. And Mathematica eliminates a lot of that headache. Next, it's got a great help menu. So all you have to do if you want to figure out how to use a particular command is just click Help, go to Wolfram Documentation, which I'll pull over here for a sec, and it's got a great search feature. So if I wanted to know more about doing 3D graphics, I just type that in. Usually it's the first thing that you search for. It's got a command that is usually pretty self-explanatory, the name of the command. You can go into the detailed description and all of the options that you can choose. And my favorite part about this is that you can run the code directly from the help menu. So here we have a 3D graphic plot of some different shapes. If I wanted to eliminate that blue cylinder, I can just eliminate it. I can just run the code directly from the help menu. I can change the color of the sphere to be green. And it gives lots of different examples that you can go ahead and play around with. Usually it has a few neat examples that it shows you. It shows you a bunch of different options. And it just makes things a lot easier to get up and running when you can run the code directly from the help menu. And when you need to have it in your project, just copy and paste that over. So it's got a great help menu. It's got thousands of built-in functions, which means, again, you don't have to spend a ton of time looking for packages to do different things for the most part. And you can get up and running and play around in a lot of different areas very quickly, even if you don't have a ton of background in them. So things like being able to play around with cloud computing. There's the Wolfram Cloud that you can play with. There's if you are interested in data science or machine learning, you could install a bunch of Python libraries, but in Mathematica, doing let's say a regression problem or a classification problem, for the most part, that's just a couple of lines of code, and then you're off and running. There is also the ability to connect to different IoT devices. So if you are playing with physics and you're doing more experimental work, you can, if the sensors that you're using have the functionality, you should be able to connect that as an IoT device and then start recording data remotely. So there's a lot of general things that are good about Mathematica. Other things that I really like, which I have not seen in a lot of other languages, is it is both symbolic and numeric. So we can, in addition to doing, your standard calculator type problems where you're doing addition and subtraction, or things like you might do in C or C++, just your basic arithmetic type problems or working with lists. Mathematica can also handle things symbolically, so I can type in an equation that looks like it would look in a physics or math book. I can do my integration. I can change this to be something else if I want. I can put a few other functions in here, and it'll do a lot of the heavy lifting for me. Other things you can do, which I really like. So just about all data types can be symbols. So we can set x equal to 3, but I could also set x equal to be a list of numbers. I could set it equal to be, even images and sound data. So if I'm just going to search for some image here really quick. And let me copy this. If I can figure out where the copy button is. Here we go. So I'm just going to set x equal to be this picture of Albert Einstein, and that works just as well. Being a symbolic language, there's a lot of neat things that you can do with that working with different data types very, very easily rather than having to import things. One of the other things I like about Mathematica is that it's very high level, so that you can do very complex tasks with very few lines of code. So for example, this is going to be a little bit of an experiment, but because I haven't tested this. So let's say I try to image identify that image of Albert Einstein I just found. So we'll try image identify X. And this is going to have to load for a second because it's pulling in some of the image classification data. And it'll tell me that that's some person. A lot of times this will actually even do better than that. It might, if it's somebody who's relatively famous, it might even tell you who the person is. And all of that just with one line of code here. I didn't have to load any packages or anything else. To give more of a physics example, so I just pulled this directly from the help menu. This is a double pendulum, also known as a chaotic pendulum. We can simulate the motion of this pendulum just with a few lines of code here. So we've got the differential equation that solves the equations of motion. We've got some algebraic constraints on how those pendulums are attached to each other. We've got the initial conditions telling us where those pendulum bobs are and what their initial velocities are. We can solve that with a command called ndsolve, and then we can animate the results. If I just plug that in really quick, you can see just with really 5 lines of code here, we get a nice simulation, and we can start doing experiments like this. I can start manipulating what those equations are, changing different parameters, and then seeing how that affects the physics. So again, because it's such a high-level language, there's a lot that you can do with even just a few lines of code. You can also make things interactive. So if I want to manipulate my data in real time, I can, here I'm manipulating a plot of a sine function. To throw in another physicsy example, again, here's one I pulled from the help menu. Here are 2 point charges, which I can adjust the relative values of those. I can also move them around in the space. We can do all of this, visualizing potentials and fields and such. This is all just done with one line of code. So there's really a lot that you can do because it's such a high-level language, and because it's an interactive, because you can make things interactive, it makes learning the physics a lot easier. Mathematica also has, Wolfram Research brands it as a computational knowledge engine, which basically means they've got a bunch of curated data that's built right into the language, which is very convenient. So for example, I can say, what is the mass of a proton? And That's just built right into the language. It'll tell me what that is. It's got really data from a bunch of sources. So if I wanted to pull in a map of the state of Iowa, it can do that for me too. It's got geographic data, it's got weather data, a whole bunch of different facts that you could look up, but it's just really convenient to have right there in the notebook waiting for you. It can also do computations on those facts. So if I give it some data and ask it to compute something, some of these are a little bit hit or miss, but it's very impressive what it can do when you give it something fun. So I'm gonna say, what is the weather in let's go Boston on what date do I want to use? We'll say Taylor Swift's birthday. So Boston is an entity that's stored in the Wolfram database. Taylor Swift is a notable person. Information about her is stored in the database, things like her date of birth, which evidently was December 13th, 1989. And I can look up what the weather was on her birthday. If I want to, I can actually plot that out. Let's see. And you can see the different times here, starting at midnight, going through noon, 6 p.m., and then all the way to midnight the next day. And you can see what the temperature did that day. Evidently very cold that day since we're in the negative numbers over here. You can also do other fun computational things. You could say things like number of pennies to cover the moon. So it knows what the moon is. It knows roughly the size of a penny. So it can give me an approximate result. In this case, it'll tell me it's about 100 quadrillion pennies. So it's a pretty impressive and fun language. There's a lot of things that you can do, again, without a real ton of work that you have to put into it. That being said, it does have some disadvantages. The most notable one, which I think is why it's not more widely used, is that it's not cheap. So it does, I think for students, even for a student license, it's within the hundreds of dollars. But if you do want to play around and you're not sure if you want to spend that and you just want to play around and do some of the exercises that we're going to go over, but not really spend any money on it, you can get a free cloud account. It's got some limitations to it. So I think if you put some code up there, it only stores that code for, I think it's like 60 days or so. But for the most part, it has all the different commands that you'll want to use, at least the ones that we're going to go over. Also, if you use Raspberry Pi, I believe you can still get Mathematica. In fact, I think it comes installed on the as part of the operating system with Raspberry Pi. So if you're a student and you can get access to a Raspberry Pi, again, you can use Mathematica that way without having to spend a ton of money on it. That's, I would say, the main disadvantage. It's Wolfram or Mathematica has gotten some criticism because it's not open source. That's kind of an advantage and a disadvantage. I love open source software, but there are some advantages to having a closed system where you don't have to worry about the you can maintain some control on how the software develops. Some other disadvantages, there is a little bit of a learning curve, but I would say the help menu and some of the online community is there is some good advice on sites like Stack Exchange, which make that learning curve a little bit easier, especially with the help menu. But that being said, it isn't as big of a community as some other languages like Python. So the amount of material you'll find online, it's definitely there, but it's not nearly as expansive as some of the open source languages. That is all for now. Thank you for watching. If you liked the video, make sure to click like, and if you'd like to see more, please subscribe. We'll see you next time.